You can use a matrix that represents a system of equations to solve the system. In this way, you do not have to write the variables. To solve the system using a matrix, use the steps for solving by elimination. Each step is a row operation. Your goal is to use row operations to get a matrix in the form as shown here. A 1 in row 1, column 1, a 0 in row 1, column 2, a 0 in row 2, column 1, and a 1 in row 2, column 2. And then we have our constants on the right-hand side of the bar. In this case, the constants are labeled A and B. Or, if we have a system in 3 equations, 1 in row 1, column 1, 1 in row 2, column 2, and 1 in row 3, column 3, and the rest zeros on the left-hand side of the bar, and then constants A, B, and C on the far right. Notice that the first matrix represents the system x equals A and y equals B, which then will be the solution of a system with 2 equations in 2 variables. The second matrix represents the system x equals A, y equals B, and z equals C, again providing the solutions to the system. Take note, key concept, row operations. The first acceptable row operation is to switch any 2 rows. So in the case of this matrix, row 1 and row 2 simply switch places. The next acceptable row operation, multiply a row by a constant. So in this case, the matrix shown here becomes the matrix shown here, but with row 2 being multiplied by 2, each term or element in row 2 multiplied by 2, forming this new row 4, -2, 6. The third acceptable matrix row operation, add 1 row to another, and then replace the row that you started with. So in this case, the matrix here becomes a row 1 of 3 plus 4, 2 plus -2, or 2 minus 2, and 5 plus 6, which then forms the simpler form of that row, 7, 0, 11. And you're allowed to combine any of these steps to transform any matrix into the forms we saw on the previous slide, allowing us to extract the solutions. Problem 4, solving a system using a matrix. What is the solution of the system shown here? X plus 4y equals -1, and 2x plus 5y equals 4. First, write the system for the matrix. 1, 4, -1 for row 1, and 2, 5, 4 for row 2. And then work to transform the matrix so that the 4 elements on the left form a 1, 0, 0, 1 pattern. As we begin that process, consider that we have a 1 in row 1, column 1, and we want that, so we'll keep that there. In fact, we'll use that in order to achieve a 0 in row 2, column 1, and that'll be our first step. We'll do that by multiplying row 1 by -2 and adding it to row 2. So now we have the 1 in row 1, column 1, but our second equation has become 0, -3, 6. So we have a 0 in row 2, column 1, and that's part of our objective. Next, let's work on row 2, column 2, and transform that -3 into a +1. We'll do that by multiplying row 2 by -1/3. Row 2 now becomes 0, 1, -2. We have a 1, 0, and 1 in position. We still need to deal with that 4. We need to transform it into a 0. We'll do that by multiplying row 2 by -4 and adding it to row 1. Now we arrive at the matrix 1, 0, 7, 0, 1, -2. That allows us to extract the solution and state the solution of the system is 7, -2. And we'll check the solution, 7, -2, by substituting into the original system of equations. The first equation checks out, and the second equation checks out. So our solution checks. Your turn, part A. What is the solution of the system 9x minus 2y equals 5 and 3x plus 7y equals 17? And part B, a reasoning item. Which method is more similar to solving a system using row operations? Is it elimination or substitution? Justify your reasoning.